Have you ever wondered what's the difference between a single bulb and a two-bulb circuit? Today, we will understand exactly that.
First, let's understand the series circuit, where all components are connected in a single line, one after the other.
The biggest drawback of a series circuit is, if even one bulb fails, the entire circuit stops working. Think of it like a train. If one coach gets disconnected, the whole train stops. That's exactly how a series circuit works.
In a series circuit, total voltage equals V1 plus V2 plus V3, meaning voltage gets divided across components.
And what about resistance? In series, total resistance equals R1 plus R2 plus R3, meaning resistance keeps increasing.
In a series circuit, current remains the same everywhere. I equals I1 equals I2 equals I3.
Now let's move to the parallel circuit, where all components are connected in separate branches.
The advantage of a parallel circuit is, if one bulb fails, the others still keep glowing. That's why homes use parallel circuits. Think of it like three separate roads. If one is closed, traffic still moves through the other routes.
In a parallel circuit, voltage remains the same. V equals V1 equals V2 equals V3 across all branches.
In parallel circuits, total resistance is given by 1 over R total equals 1 over R1 over R3, meaning resistance decreases.
And current, in parallel circuits, total current equals I1 plus I2 plus I3. It splits across branches. Now let's quickly compare both circuits, series and parallel, so the difference becomes crystal clear. In house wiring, we use parallel circuits so that even if one appliance is off, others keep working. Old Christmas lights used to be in series. If one bulb went off, the entire string would stop working. Remember Ohm's law, V equals IR? This is the foundation of both these circuits. To summarize, in series, resistance increases, voltage divides, current stays same. In parallel, resistance decreases, voltage stays same, current divides.
So friends, now you clearly understand the difference between series and parallel circuits and where each is used.
And if you want more detailed lessons like this, check out our previous video shown on screen. Don't forget to like and subscribe.